Okay, again, we're eliminating parameters, which of course we did the first day when we were graphing. You're just trying to get rid of the t's, trying to get rid of the trig functions if there are any, and just write something in terms of x and y. So, first thing I'm going to do is I'm actually going to subtract 2. So x minus 2 equals secant t. And then the second one, I am going to subtract 5, y minus 5 equals 2 tangent t, and of course I want to divide both sides by 2, so y minus 5 over 2 equals the tangent of t. And again, same Pythagorean identities that we've been using, so we're just going to use secant squared minus tangent squared. Okay, so secant squared minus tangent squared equals a 1. And plug in what we got. We got an x minus 2 for secant, quantity squared, minus, for our tangent, we have a y minus 5 over 2, quantity squared equals a 1. So this is really an x minus 2 quantity squared. You can put it over a 1 if you want to, minus a y minus 5 quantity squared over a 4 equals a 1. So that is our equation with the t parameter eliminated. Now again, I think it was number 3. Okay, we graphed it and we did zoom 6 for that because the parameters for the other one were 0 to 2 pi. For this one, it's 0 to pi over 2. So again, go and graph it, right? X equals 2 plus 1 over cosine, x1, and then y1 equals 5 plus 2 times the tangent of t. But I don't want you to hit zoom 6 this time. I actually want you to hit your window, okay? And we should be in degree mode. So your window, when you hit that button, your T min should be the 0, and your T max will be, since we're in degree mode, you're going to do 90 instead of pi over 2. I want you to do that and then hit graph. And what you see is you'll see a graph that basically, where x is 1, 2, 3, your graph starts, we'll go there. Your graph starts here, right? That little red squiggle is supposed to be your graph. But it starts at x is greater than 3, or x is greater than or equal to 3. No, we'll do greater than. Okay? And so, and we're doing greater than because we have, just less thans in our inequality over there. But that's how we can find the x parameter, the parameter, or the restrictions on x, I should say. Okay? Again, just with the graph, but the only thing that was different is we had to, we had to make sure that we were 0 to 90 degrees. All right, let's finish up number 6. Eliminate the parameter, write the resulting equation in standard form. You will notice that there's no inequality for t, so there are no restrictions on t. So at this point, we really just want to get an equation of a circle, and we're dealing with x equals 5 plus 4 cosine t, and y equals 2 plus 4 sine t. And at this point, guys, remember, you're just going to basically get the trig function by itself. So x minus 5 equals 4 cosine t, and y minus 2 equals 4 sine t. Oh, and then we've got x minus 5 over 4 equals cosine t, and y minus 2 over 4 equals the sine of t. And then, guys, your Pythagorean identity is sine squared plus cosine squared equals 1. So, and actually, we have to write it just a tiny bit differently. And the only reason is because we want to write it in terms of a circle. So we're going to write it cosine squared first plus sine squared equals 1. The reason being, remember, circles are x minus something squared plus y minus something squared equals 1. So we write this as an x minus a 5 quantity squared over a 16. I'm just squaring everything as I'm entering this, or substituting it in. And y minus 2 quantity squared over a 16 equals a 1. Technically, we want to multiply everything by 16. So you get x minus 5 squared plus y minus 2 squared equals 16. So your equation is a circle with a radius of 4, right, square root of 16, and a center of 5, 2. And that's it.